Kia ora, here comes the second video from the Level 3 Calculus exam papers. This is 2E from Differentiation. This is a related rates of change question, and I think that although there are a couple of different ways you could do it, it's a pretty straightforward one as long as you go slowly, and as soon as you see that the problem's about a cylinder, you think about whether we're looking for the lid of the cylinder and the base of the cylinder. Okay, so we're given the volume of a closed cylinder, right, important, highlight that, with a fixed height of 7 centimetres. And the volume is increasing weirdly at a constant rate of 26 cubic centimetres per second. We have to figure out the rate of increase of the surface area when the surface area is 190 centimetres cubed. So let's just start by writing down what we've got. I'll just shrink this a little bit. And I don't know why the questions come up twice, but there you go. So just starting from what we know, well, the surface area of a cylinder has got a top and a bottom lid. So that's going to be two circles, so 2 pi r squared. And then it's got the rectangle, and you're given this on your formula sheet, but that rectangle has one length, so the base is going to be the circumference of that circle, so it's 2 pi rh. So it's 2 pi r there, and it's h there. So that's my expression for area, and we know that the volume of a cylinder is simply pi r squared h. Right, what we're asked to work out here is we need to find dA by dt when A is equal to 190. Now, straight away here, we're told that we've got a fixed height of 7 centimetres. So this is actually quite an easy problem because I can substitute in h equals 7. That gives me A is equal to 2 pi r squared plus 14 pi r. And V is equal to, what have we got, 7 pi r squared. So we know that we're going to be linking up all of our rates with the chain rule, so I might as well straight away differentiate and get dA by dr. dA by dr is 4 pi r plus 14 pi, and dV by dr is equal to 14 pi r. So our goal is to find dA by dt when A is equal to 190. Now, what we're going to do is set A equal to 190, and now we're going to solve this quadratic to get a value of R. Then we're going to link up the rates. So for this example, like you know, if you're in my class, how much I sometimes loathe our dependence on calculators, but I would totally do this question with my graphics calculator to get the two solutions for the quadratic formula, right? You're under time pressure in the exam. It's a calculus exam. It's not a level 2 algebra exam, so it's fine to just bung that in the calculator and get out two values of R. So R is equal to 3.018 or negative 10.018. So that's not valid because R has to be positive. So this is the value of R that we're going to be using. All right, so now it's time to do the link up. Lots of ways to do this. My favourite way is just to look for a link up chain rule thing. So we're going to have dA by d something. Well, we've already got dA by dr. We know that we were given dV by dt. And so linking those two up in the middle, we're going to have how the radius changes when volume changes by a bit. We were given that dV by dr, I think, was 26. Yep, so 26 cubic centimetres per second. That means that dr by dV is equal to 1 over 26. Okay, so we've got this. That's not right. That's not dV by dr. That's dV by dt. Okay, we fixed that up. dr by dV is not 1 over 26. dr by dV will be the reciprocal of this thing here, so it's 1 over 14 pi r. So putting that all together gives me 4 pi r plus 14 pi divided by 14 pi r, right, so there's that done and that done, times 26. So you can either substitute in your r now and bung it all in your calculator, or you can do a little bit of cleaning up. We get 2/7 for that first term, and then 1 over r times 26. Not too much messy substitution. we now pop in 3.018. Where's it gone? Sorry about that. My laptop did the weird glitching thing. So we're going to have 2/7 plus 1 over 3.018 times 26. You don't need to do that simplification there. Most of you probably didn't. Just be really careful with your calculator that you are putting brackets around the numerator. And that gives me a final answer of 16.04 square centimetres per second. Now, if you're watching this, you probably are confident with the units on rates of change things, but remember that we're finding the rate of change of the surface area with respect to time. So that's how come we've got centimetres squared here, because that's the unit for area, and we've got seconds here because that's the unit for time. All right, so I think a pretty nice excellence question. As long as you're good at forming the chain rule relationship, there's not really too many traps in there. So I think lots of people in my class got that question, did that question really well. I'll be back later on tonight or tomorrow to do the last of the differentiation excellence ones and then into the complex numbers problems. Email me if you've got any that you'd like me to do first. Thanks for watching.